5 seconds.
Liftoff normal. P1 tracking. PC tracking.
Magnificent liftoff of PSLV C-57 with Aditya-L1 on board.
As Aditya-L1 successfully makes its way to the final spot in the universe, in orbit 1.5 million kilometers from Earth, the big question: what will Aditya-L1 achieve, and how will it add to our knowledge about the universe? We know that the Sun is the reason we exist, survive and flourish. Earth and other planets in the solar system were formed from stellar material that was left after the formation of the Sun was complete. The Sun not only formed the Earth, but is responsible for the sustenance of life as well. All our energy sources are linked to the Sun. In addition to its central role in the solar system, the Sun also has an effect on interstellar medium, which is the extremely thin medium found between the stars. Charged particles given off by the Sun interact with the interstellar medium and give rise to phenomena such as heliosheath and heliopause. Studying the Sun will not only give us insights into our immediate near-Earth space, but it also has the potential to improve our understanding of other stars in the universe. Aditya literally means the Sun in Sanskrit. The spacecraft, after launch, will be placed in a halo orbit around Lagrange point L1 in space. This point is about 1.5 million kilometers from the Earth. There is a major advantage in placing the observation spacecraft at the L1 point. The spacecraft at this point will be able to view the Sun without any obstruction or eclipse. This will allow Aditya-L1 to observe solar activities and its effect on space weather in real time. Aditya-L1 will carry 7 payloads to observe the Sun's photosphere, chromosphere and corona, the outermost layer, with the help of electromagnetic and particle and magnetic field detectors. The Sun constantly emits charged particles. The Aditya-L1 will study these particles. The Indian Space Research Organisation says on its website that this will provide important scientific studies of the propagatory effects of solar dynamics in the interplanetary medium. ISRO expects that Aditya-L1 payloads will give us important information which will lead to understanding coronal heating, coronal mass ejection, pre-flare and flare activities and their characters. In addition, the observations made will also let us understand dynamics of space weather as well as propagation of particles and fields. Lagrange points are 5 locations in space around the Earth where gravitational forces of the Earth and the Sun along with the orbital motion of the spacecraft interact in order to create a stable location. These are called Lagrangian or L1 points. These are named after 18th century Italian astronomer and mathematician Joseph Louis Lagrange. The points are denoted as L1, L2, L3, L4 and L5. The ambitious Aditya-L1 mission plans to study the Sun's upper atmosphere, the chromosphere and the corona. It will also study chromospheric and coronal heating, the physics of partially ionized plasma, initiation of coronal mass ejections and flares. The mission will observe in situ particle and plasma environment, which will provide data for the study of particle dynamics from the Sun. The Aditya-L1 plans to study the physics of solar corona and its heating mechanism. ISRO will observe diagnostics of the coronal and coronal loop plasma. These include temperature, velocity and density. The mission will also study the development, dynamics and origin of CMEs or coronal mass ejections. The Aditya-L1 will attempt to identify the sequence of processes that occur at multiple layers of the Sun. These processes eventually lead to solar eruptive events. The Aditya-L1 will also observe and study what drives the weather on the Sun or space weather. Aditya-L1 has been placed in a low Earth orbit by ISRO's PSLV C-57 rocket. After that, the spacecraft's orbit will be made more elliptical. On-board propulsion will be used to launch the spacecraft towards L1 point. As it moves towards L1, the spacecraft will exit Earth's gravitational sphere of influence. After that, the spacecraft will begin its cruise phase. It will then be placed in a large halo orbit around the L1 point. The spacecraft will take 4 months to reach its destination about 120 days later in January 2024. This is the Lagrange point 1 or L1. L1 lies along the Sun-Earth line and is located 1.5 million kilometers from the Earth. Lagrange points are special positions in space which allow a spacecraft to save fuel because the gravitational pulls of large masses act in such a way that they become balanced and cause the spacecraft to stay in a fixed position. Since Aditya-L1 will be placed in a halo orbit around L1, not only will the observatory be able to conserve energy and remain fixed in the orbit, but will also obtain an uninterrupted view of the Sun throughout the entirety of its mission life. This is because at L1 there are no eclipses or obstructions, and the Aditya-L1 can perform scientific experiments continuously for 5 years. The distance between the Sun and the Earth is about 150 kilometers, and that between the Aditya-L1 spacecraft and the Earth will be 1.5 million kilometers. This means that the distance between Aditya-L1 and the Sun will be about 148.5 million kilometers. ISRO chose 1.5 million kilometers as the distance between Aditya-L1 and the Earth after careful consideration. 1. L1 will allow Aditya-L1 to enjoy an uninterrupted view of the Sun for its entire mission life. 2. L1 offers a unique gravitational balance between the Earth and the Sun. Since the gravitational forces of the Earth and the Sun cancel each other out, Aditya-L1 will be able to maintain a stable position with low energy expenditure. Every planet, including Earth and the exoplanets beyond the solar system, evolve. This evolution is governed by its parent star. The solar weather and environment affect the weather of the entire system. Variations in this weather can change the orbits of satellites or shorten their lives, interfere with or damage onboard electronics. They can cause power blackouts and other disturbances on Earth. Knowledge of solar events is key to understanding space weather. To learn about and track Earth-directed storms and to predict their impact, continuous solar observations are needed. Every storm that emerges from the Sun and heads towards Earth passes through L1. This was all for this video. Thank you for watching.